Grab your popcorn and snacks. Find a comfy spot, take a seat or lie down, and let me transport you to a place of fantasy, ghost stories, ancient legends, odd creatures, alien encounters, and other magical topics. You may even decide to join the conversation. From faraway lands to your own backyard, with a small dash of pixie dust, turn out the lights and open your minds. The journey is about to begin. Good evening, Monday evening, start of a new week. Let me push my buttons. There we go. I got my buttons pushed. You know how I'm about my buttons. Anyway, welcome everybody. It's good to see you all. We're a little later this evening, but I've got a great guest lined up. My name is Charlotte. I'm going to be your host for the next hour. And I am also the owner of the California Haunts Paranormal Investigation Team based out of Sacramento, California. You can find us at www.californiahaunts.org. But if you're really interested with the radio show, that's a totally different website. So that's californiahauntsradio.com to check us out. You can see, like right now, we're live there, as well as YouTube, Twitter, and oh yes, and Facebook. See, I have to be reminded of these things. It's late for me. I've been up since 5 a.m., so that's a switch. If you're watching us from YouTube, please subscribe. And you're new to our show, please subscribe. Hit the down the right-hand corner. There's a little ghost with a Sherlock Holmes hat on and a magnifying glass, and click on that because that's our mascot. That'll get you to subscribe. We've got over 200 shows there, and you can look and see who our guests have been in the past and what's going on with us. Anyway, to tonight's guest, he's a professor. I am a space nut. You guys know this. Not only do I keep an eye on what's going on with all the rockets and stuff, I have a 12-inch telescope. And so I'm out front like everybody else checking stuff out. I'm outside with the meteor showers. I've heard those things whizzing down through the atmosphere. And I'm fascinated by what this gentleman has to say. His name is Professor Gregory Brennecka. We're going to be talking about meteors and how they helped get everything started on Earth and whatnot. And, other stuff too as well. But I'm really excited to have him on. And without further ado, let me do this. Hello, sir.
Hi, how's it going?
Really good. How are you?
Excellent. Yes, doing well.
Tell us a little bit about you and how you got into doing what you do, sir.
Well, I grew up in Missouri, kind of in the rural parts of Kansas City area, and I studied geology as an undergraduate. So basically just looking at terrestrial rocks and kind of history of the planet. And then when I got to graduate school, I was introduced to meteorites. And I guess ever since I started looking at meteorites, I never looked back at terrestrial rocks. I kept my eyes to the stars and really enjoy kind of learning about the history of the solar system and everything that meteorites can tell us.
Fantastic. I remember reading a book back in the old days. I'm not going to say how old I am, okay? I had this set of encyclopedias, and at that point, I'll just say that, they were at the point that men were going to go to ride rockets to the moon. That's where they were at. But I remember seeing something, and I just want to ask you about this. They used to have projects in there for kids. And one of the projects was to go onto your roof and put a white sheet on your roof.
Mm-hmm.
Because they said that the metal from meteorites is constantly falling through the atmosphere. So if you got up there with a magnet, you could actually pick up the metal. Is that true?
Kind of, yes. So
Okay.
that actually does happen. A lot of the stuff we get nowadays is fly ash, and not just meteorites, but we actually add like 100 tons of meteoritic material to Earth every day. So the chance of some falling on the roof is not zero. So
Okay.
yeah.
Well, let's talk about this stuff because I know you have your book out, and there's that theory about the meteorite that hit the Earth and then everything changed, and the dinosaurs died and all that. But you mentioned on another show how you feel that a meteor had at some point had some impact that impacted life on Earth itself, which would include the dinosaurs, but how it influenced the human race coming up.
Yeah. So I guess kind of there's a lot of meteorites that have kind of changed the influence or changed the direction of humanity, and it kind of starts very early on, with the formation of the moon, and we're talking 4.4 billion years ago. So that was probably the first really important meteorite impact that basically hit the Earth. A very large meteorite about the size of Mars hit the Earth, which is, kind of hard to think about even the size of that and the impact that caused. But that's how we got the moon. And what that did is kind of blow off the atmosphere of early Earth and kind of allow life to maybe develop after that, because otherwise we'd be very similar to Venus and have an atmosphere that was mostly carbon dioxide and sulfuric acid and things like that, like Venus does. And thanks to the moon forming impact, we don't have that, and we have a much cleaner atmosphere and kind of developed the way that we did because of that. So that's kind of how it all started. And then, every meteorite impact since then has had an interesting influence, as we go through history.
Where is the biggest meteorite impact on the Earth?
Well, there's probably been many that have been erased due to plate tectonics. The largest one, I believe, is in South Africa.
Okay.
There's a kind of a hidden crater that they found while they were mining for basically granite countertops. So that's how they found it, was a big crater.
Yeah, I've been out to the one in Arizona. I mean,
Meteor Crater?
Yeah.
It's spectacular, isn't it?
Oh my God, it's incredible to see.
Yeah.
It's hard to imagine that at one time, those things were hitting the Earth. I mean, like I said, I've been outside during the Perseids.
Mm-hmm.
Sometimes you could hear them coming down through the atmosphere. They have a certain noise.
It's pretty interesting, yeah.
Yeah, it's pretty interesting. And it just amazes me that more don't hit the Earth, or are they hitting and we just don't realize it?
They are hitting. The big ones are pretty rare. So the one you're talking about, Meteor Crater, which is a pretty impressive hole in the ground. That one, happened thousands of years ago. But large ones are pretty rare, luckily for humans. But we get a lot of softball-sized ones. I don't know for the viewers that can see. We get a lot of sizes like this that are coming down quite a bit. But the big ones are rare, luckily. But they do still happen.
That's it. It blows me away. That it's going to happen because they're going to fall, obviously. It's like anything else. I mean, look at Skylab, right? Down it came. When you talk about, people let's go back to the dinosaurs a little bit here. How long? I mean, it didn't happen obviously, there was an impact, but it didn't happen overnight for these things to go extinct, or did it happen that quickly once the meteor hit?
It's kind of hard to tell geologically. I mean, geologically, they went extinct very, very quickly. I think a lot of researchers believe the dinosaurs were already in decline before this impact happened.
Mm-hmm.
But there's certainly dinosaurs existed before the impact, and then they didn't exist after the impact. So whether it was a direct cause of all the dinosaurs dying, or just a lot of them is kind of, to me, it doesn't really matter. It was really bad for them if all of them died out.
Right.
You think about, they had these giant planet or building-sized lizards walking around the planet. In the blink of an eye, you have nothing alive that's larger than a basset hound. So it was a pretty big deal when it happened.
Well, my question is this: I mean, if the meteor is big enough, like you were talking about, something the size of planet Mars, that could knock the Earth off of where its axis, or off of where it's at, right?
Well, I mean, totally flash melts the whole planet. Yeah, so something that large it entirely melts the planet. So that would extinguish all life on the planet for sure. But so hopefully we don't have something that large hit us.
That's just absolutely fascinating to me, to think that there's stuff up, still floating above us that size. You know what I mean?
Yeah, it's kind of scary.
Come down. It's just
luckily we've identified what we think are most of them out there and paying attention. But
it's just fascinating and terrifying at the same time.
It is. That's life, though, I guess, right?
Are there? I know this is going to sound silly to you, but are there, you look at stuff like Star Trek and Star Wars and these different shows when they fly through the asteroid belts and the meteor belts? Are there areas like that up there?
Well, I mean, I'm a huge fan of both of those that you mentioned. One of my favorite scenes is, of course, the Millennium Falcon going through the asteroid, where that area was. I think that's maybe a little bit dramatic because they're so densely packed. In our own asteroid belt, they're not that densely packed. I mean, there's a lot of material up there, but space is huge. It's really, really huge. So the distance between the objects is quite large. So it's not a problem to, fly a spaceship through it. We've done it many times. in sending things to the outer solar system.
And what are these meteors made out of?
A lot of different things, actually. There's a huge diversity in what the different meteorites we get are. And they can be from like the cores of planets, which are basically pure iron and nickel. And then they can be very similar to like a Hawaiian volcano basalt like that. There's also things that have never been melted. Rocks that basically form from gravity of just gas and dust coalescing in the outer solar system. So there's a huge variety of things that we don't have on Earth, or we don't have access to on Earth outside of meteorites, which I think is another thing that makes them so scientifically interesting, and not just cool and beautiful, but they're just simply rocks we don't have access to on Earth.
And I know there used to be, I don't know if they're still on, but there used to be guys on either the History Channel or Discovery Channel that used to go out with metal detectors looking for these things.
Yeah, Meteorite Men, I believe was the show for a couple of years. Yeah.
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 Yeah. I would love to find something like that. It would be really, really cool to have one.
Yeah, I've been searching a few times. I went out with a few different, professional meteorite hunters, and I was actually able to be with Neil deGrasse Tyson on one of his shows in Nova, and when I was a graduate student, and we went out looking in the Arizona desert, and we didn't find anything, but it was fun to just kind of hang out for the day and walk around and look.
Yeah. I mean, that would be a blast. I know my brother-in-law and I used to go bottle digging, so it's got to be something similar, except now you use metal detectors to find these things,
Exactly, yeah.
How fast does a meteor travel?
They have a lot of different speeds, but generally you can think of them about 25 times the speed of a bullet. So these things are moving real fast. So some are of course a little bit slower, and some are a little bit faster, but that's kind of generally how I think about it. So I'll mess it up, but I think it's like 60,000 miles an hour or something like that. But I always think of it as kind of 25 times the speed of a bullet.
Wow, it's hard to imagine.
It's fast. Yeah.
I mean, I could think about that because, like I said, people don't realize, that some of them make a sound when they come through the atmosphere. That's a weird sound. I'm laying by my house, and I hear this, go down, and I'm like, what is that? You're thinking it's close, but it's not, because it's, like it's way up like that. Let's talk about the moon a little bit and compare that to the Earth. Why do you think the moon has had so much more? Well, is it because of the atmosphere of the moon that they get through faster? To have the impacts it's had, or it's just been around longer?
Yeah, it's a variety of things, actually. So a lot of it is that the moon doesn't have the atmosphere that the Earth has. So you're right, exactly, that they don't burn up in the atmosphere of the moon. But the biggest part is probably that we have oceans and plate tectonics. So the Earth is quite large, and 70% of it is covered by water. So we don't see the craters that hit the water. And then also, plate tectonics basically erases everything, over time. So we only see the craters that exist on, the land that is new and hasn't been recycled.
Okay.
So, eventually Meteor Crater is going to be subducted and, destroyed. So, things that happened a couple billion years ago have been erased, whereas that's not the case on the moon. So we see those scars basically forever on the moon, whereas we don't see them forever on Earth.
How does one study meteorites? I mean, obviously you're not going into space to check these things out. So, as a professor, studying this, how do you do it?
Well, you're kind of onto something about going to the meteorite, though. We are doing that actually right now.
Okay.
So for my job, of course, we study meteorites that have already fallen, and that are collected around the world and in museums and things. But there's NASA space missions, and then the Japanese space mission Hayabusa just collected part of an asteroid and is bringing it back. So I get really excited about those two missions. The NASA's is called OSIRIS-REx, and they're basically going to scoop up pieces of meteorites that, well, I guess they're asteroids. They haven't landed yet, but they're just basically going to go get them as opposed to waiting for them to fall. So.
That's very interesting. And so then it comes back to you guys, and so I mean, how do you analyze them once you get them?
Yeah, so there's a lot of different branches about how people study these things. Of course, with very precious material, you don't want to destroy it until you've gotten all the information you can out of it. So let's say we get a new cool meteorite in, we don't immediately dissolve it. First of all, we'll look at it under an SEM, or really get very nice pictures of it and use a nice microscope, and then we make thin sections of it to try to figure out what the mineralogy is. So we kind of go through this process of non-destructive to more and more destructive until we end up basically dissolving the whole thing to try to figure out exactly what it's made of. And of course, I say the whole thing. I mean, we only need tiny chips of the meteorite generally to do this type of work. So we only take small bits of it, but those small bits end up being destroyed.
Well, the question I have is, how do you dissolve it then? I mean, if it's a rock or it's metal or whatever.
Usually there's just some strong acids we use, hydrochloric acid, nitric acid, things like this. They dissolve rocks. You just crush it up and dissolve it.
Okay.
So you have to deal with a lot of strong acids, but we're used to that. So.
and do they have any microbes on them or anything that you guys have to be aware of? Because you are bringing stuff from space, to Earth.
Yeah, so space is pretty sterile. The UV radiation, and there's no life really on these things. Of course, they have amino acids in them and things like that, but it's not life. So it's not like it's going to contaminate us. We're obviously more worried about contaminating meteorite than we are the meteorite contaminating us. Okay. we try to protect the meteorite from us, basically, with clean labs and clean lab procedures, because we don't want to drop something on the meteorite and then be fooled that it came from space when it actually came from my finger or my hair or something like that. So that's why we put in the clean lab procedures that we do.
Are you guys able to do? I don't know if they use carbon dating now or what they use now, but are you able to get like dates on how old these things are?
Yeah, actually, that's what I normally do. That's one of the types of research that I spend a lot of my time doing is trying to figure out exactly how old each of these meteorites are, and to kind of reconstruct what order they formed in. So yeah, we don't use carbon dating because carbon dating only works, for a few thousand years. But there are other types of things that are similar to carbon dating, only with different elements that work, for hundreds of millions to billions of years. So
what's the oldest? Huh?
Go ahead. Sorry.
No, what's the oldest meteorite that you've ever worked on?
The oldest thing in the solar system, which I was fortunate enough to work on, is something called a calcium aluminum-rich inclusion, and it's actually a little piece that's contained in a meteorite, and it's 4.567 billion years old. So, over 4.5 billion years old. It's pretty ancient.
It's a long, long time ago in a
galaxy.
It's a long time ago.
Yeah, and it predates the moon by 200 million years. So. Predates dinosaurs by 3.5 billion. So
that just boggles the mind.
Yeah, it's crazy. It's crazy. And it started about the same time. I mean, the sun and the solids that formed the solar system happened about the same time. So it's as old as the sun. Within error, basically. They all kind of, the sun started, and then all the solids started to form. And that's actually how we date the age of the solar system.
Wow. All I can say is, that just blows my mind. That goes back. I mean, obviously it goes far, but I mean, to actually find something from that time period is incredible.
Yeah, it is. It really kind of puts things in perspective about, like my birthday or something like that. Does that really matter on a geologic time scale? And the answer is not at all.
It's just too bad that, we don't have the technology to figure out exactly where they came from.
Yeah, we're getting close though. I mean, we have. So you mentioned kind of meteor showers. There's an interesting study that people have started over the last 10 years or so. Basically, they set up cameras to try to capture these things flying into the atmosphere. And when you've got 3 or more cameras, you can do something called triangulation that allows you to kind of triangulate where the streak came from and where it lands. So that allows you to find the meteorite. But it also allows you to calculate where it came from in the asteroid belt. So we actually can kind of calculate back where it was living before it got, jettisoned and started heading our direction, which I think is a pretty cool use of, cameras and math.
That is just so cool. I should have gone into science, I tell you, because I was so into this stuff.
Yeah, but then who would do broadcasting? Come on.
That's it. Because I love physical science. I'll tell you that was my thing in high school, man. I just love physical
It's really
science.
fun, yeah.
Oh yeah, because it's a little bit of everything, you know. Um, so how many meteorites have you actually like studied?
Oh, good question. I don't know, probably 300. I don't know. I'm just kind of taking a guess. There's something like, I don't know, 60,000 in the world's collections. So there's a lot out there that obviously I haven't studied.
Hmm.
But yeah, I've probably been involved in a lot, studying quite a few different types, and I'd say probably between 2 and 300 or so. Um,
Who
but
tracks
that's
them?
just a random guess. It's
Well, who tracks them?
so there's a lot of traction coming into the atmosphere, or traction once they've landed and like
Coming
are
through the
cataloged.
atmosphere, because I know there's always you always get those warnings every once in a while about a super asteroid or a super meteorite. So who is doing these? Who's
So
looking?
there's something in NASA called Planetary Protection.
Mhm.
It's an agency that's part of NASA. So they're basically the ones pointing the telescopes to the sky, looking for these objects that may cross Earth's orbit and have a serious problem. But they're only looking for things that are big. There's really no way to track until it enters the atmosphere. There's no way to track something the size of a basketball or a softball or something like that, just because you're not gonna see it with the telescope. It's too dark. It's too small.
Mhm.
And it doesn't really cause that much damage unless it hits you or your car.
Right, right, right.
Then of course it'll cause some damage, but the chances are pretty low.
My next question is now if they're able to like track something like that, can they deflect it with a missile or something to keep it away from us, or do we just have to brace for impact?
So that's another really cool mission that's happening right now. Is basically the DART mission is a NASA and ESA mission, which is a European Space Agency. We're actually testing this capability to if we see something coming our way, can we hit it with something to redirect it away from us? And right now they're testing it on an asteroid that's not going to hit us. Of course, it's not even close. But we're testing the capability and also to see how much it actually changes the trajectory of the asteroid.
Interesting. Very
Again, it's
interesting.
pretty cool use of math to be able to basically shoot up a rocket essentially and hit something that's moving 25 times the speed of a bullet, thousands and thousands of kilometers away.
What do you like so much about studying these things?
um I would say just the fact that we're learning stuff about the early solar system that we didn't know before. I guess it kind of goes back to any scientist, is that you're just looking for answers, and you're just trying to figure stuff out. And we try to go into these with no preconceived notions about what was going on and just take it where the data leads us. And I think it's just really interesting to take a piece of the early solar system and try to figure out what happened. I
Mhm.
kind of like to look at it as like a forensics exercise, and you're just kind of trying to figure out what happened.
Let me ask you this: I've seen the moon rocks and that on display at the Smithsonian and whatnot. Is there? I mean, what's the difference between say the rocks on the moon and an asteroid?
Well, the rocks on the moon are quite depleted in a lot of things because of the giant impact
Hmm.
that caused the moon. So they actually have a lot less iron, for example, than a lot of the meteorites. They have a different type of rock. So it's a very plagioclase is the mineral, which is very common on the moon. So they have a different mineralogy, and they have a lot less volatile elements in most cases.
Okay, okay, and I think they're a lot lighter too, aren't they?
They're a lot lighter in color. Yeah, they are.
Yeah, yeah.
Definitely, yeah. And that's the
That
plagioclase because it contains a lot of, light colored minerals, things like that.
so on during any given week, say here on Earth, there's meteorites falling all the time. They're just not big enough for us to notice, right?
Yeah, yeah. Like I said, there's about 100 tons that are happening every day. Most of them are just really small, of course, and they're sand-sized particles that are falling on people's roofs, and they don't, they're never noticed. But
Mhm.
occasionally we do get, and every day probably there's something the size of a softball or something like that coming down, and most of them, of course, go unnoticed and unseen.
Mhm.
But we're adding a lot of meteorites every day.
My other question is too. You used to hear of a lot of meteorite hits, like I hate to say Russia, but some of those, some of those villages way out.
Mhm.
Is that just because, there's like, because we're so busy here in the cities, we don't notice that stuff. Whereas, is it because, like I said, it's a village in the middle of nowhere, and that's probably why they notice it more?
Well, I mean, if it's a village and there's a lot of how do I say this? There's a lot of space out there, and
Mhm.
Russia's huge, for example. The middle of the U.S. is huge, and if you don't have light pollution, from Chicago or from Moscow or something like that, it's easier to notice these types of things.
Mhm.
And so that's one reason. But also, just the vast majority of land is rural areas.
Right.
So you think, oh, it's in the middle of nowhere. Well, the middle of nowhere is like 95% of the planet.
Right. 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 Right.
So maybe that's why.
And it makes me wonder, like even around my own neighborhood, not all the time, but there's certain times of the year where you'll hear an explosion and nobody knows what it is.
Mhm.
And it always makes me wonder whether or not, something impacted.
Yeah, I mean, so there's actually a lot of what are called meteoritic air bursts. So
Hmm.
it's a meteor will be coming in and then blow up in the atmosphere because it's heating up so much as it going through the atmosphere. So you won't necessarily get chunks of that meteorite, but it'll make a big bang.
See, that
And you
makes
may get really small chunks of it, of course, but it won't be a large meteorite that makes any damage or anything like that. But you'll still hear it. So that definitely could be something that is happening.
See, that makes a lot of sense. That makes a lot more sense because yeah, it's not so much now, but I think it happens a lot. Like you said, I think it happens a lot during like the Perseids, and people don't realize it because I see a lot of reports coming in over next door and stuff, like that, where there's these explosions nobody can explain. So it makes sense. That's cool. I'm learning so much tonight. So, are you a backyard astronomer too?
I'm not that much of one. I love looking at, astronomic news
Mhm.
and astronomy reports and things, but I don't have a telescope. I guess I let other people do the work for me and I just reap the benefits of what they find. I think it's really cool, but I just never really, got into it and bought a telescope and started doing it myself. I just, I've got some friends that do it and I enjoy going over there and looking at their telescopes, but I haven't done it myself.
What's a typical day like for somebody like you that studies these things?
Oh, prepare to be bored. No, I mean, I guess a lot of it is chemistry. So, when we get one of these things, and we talked about radiometric dating.
Hmm.
So, in order to get, like, for instance, I've worked on some Martian meteorites, and to try to get the age of these Martian meteorites, what you do is basically separate the different mineral fractions from one another. So you end up crushing the meteorite really gently to try to separate, plagioclase from pyroxene and, all the different minerals that exist. So that takes a lot of time. So you have to sit there under a microscope and pick out the different colors. And then, of course, you have to clean that and then, dissolve it in acid and, then separate the elements that you want. So, that process itself takes, months to, sometimes even a year to do that, to get to an actual age of a meteorite. And then, of course, after you finish the chemistry, there's the mass spectrometry, which is how you basically create the data of what elements are in there. Um,
Now,
so
my question is this too. I just thought about that when you said a Mars meteorite. Are the ones that hit Mars different material than the ones that hit here?
probably not. So they found quite a few meteorites that have hit Mars as they were driving around with the rovers. So they basically would drive around and say, okay, that's a meteorite we just found. But they're all from the asteroid belt for the most part. So
Okay.
they're made of basically the same materials. I mean, of course, there's a wide diversity of stuff, like I said earlier. But there's no reason that it should be any different that lands on Mars that lands on Earth or the Moon or something like that.
Yeah, I was just wondering because Mars is further out. If maybe they're coming from some other direction or just some other area
Yeah,
to
there.
impact.
Although within the solar system, we're pretty close to Mars. I mean, we're neighbors essentially. When you think about how far out things are,
Mhm.
it would be like going to your house or your neighbor's house, and coming from Paris.
So now that you guys and once you guys study these things, what do you do with them?
After we study them, or um, usually we only, let's say we need to look at a meteorite, we would buy, I don't know, 5 grams of it, something like this, or get it from a museum. And
Okay.
usually we use what we get. And then, of course, if there are leftovers, we leave it for later studies, or if we need a comparison for a different study, you always end up with a little bit in your drawer left over. But we usually use what we ask for the most part. Of course, I've bought a few of my own just for fun, and they're nice display things. But the ones that we do for study and for academics, we usually use most of the meteorite that we ask for.
Wait, see, I just lost the question I was going to ask about that too. Oh, what is the most interesting meteorite that you've studied so far?
Ooh, that's a good question. Like picking a favorite child or something, right? I would say, to me, Murchison meteorite is probably
Okay.
the most interesting that I've worked on, because it contains a lot of these really old things that I was talking about earlier, the oldest things in the solar system. But it also contains a ridiculous amount of organic material. And I don't mean organic material in that like it was life, but it contains a lot of things that are the building blocks of life. So like amino acids and parts that make up our DNA, and alcohols and ketones and all these biological type words that are thrown out in high school biology. There are a lot of them are contained within Murchison meteorite and similar types to that. And when I learned that in graduate school, it just blew my mind that there's stuff out there that is formed in space in the outer solar system, and then brought to Earth or brought to the terrestrial planets, and then probably seeded life itself, as basically the raw ingredients, not necessarily bringing life, but bringing the ingredients that allowed life to kind of get started. So that's probably my favorite meteorite.
See, that blows my mind too, to try and wrap my head around it, because it's literally a rock that has hit the Earth. So what happens when it breaks apart? It mixes in with the soil here, or it mixes in with the water, that it just starts to create life, or how's that work?
Well, that's a great. I don't have an answer for you, but yeah, I mean, the early Earth was a location that probably was very reduced atmosphere, so there was a lot of energy available, and then you've got kind of this organic material that's raining down all the time, and it finds water, it finds a kind of a happy place, and how life gets started, I won't even pretend to say that I know. But
Right.
I do think that the ingredients came from meteorites.
That's neat. That is really neat. Show us your meteorite again. Somebody wants to see your meteor.
All right. So this is just an ordinary. Well, I don't know if you can see the camera here. This is just an ordinary chondrite that's been cut in half. So you can kind of see some differences there. And I've got another one. This one is an iron meteorite. Let me open up the bag here. So this one represents kind of the center of a planet. So if you can kind of see let me get the camera up to it. You can kind of see the different minerals in there. So those are only formed at really high pressures and temperatures. And we can't even do this on Earth. We can't kind of fake this. It only happens in the centers of planets and asteroids. So I think that's pretty cool. It's basically just pure iron and nickel.
Okay, so now my next question. So you just opened up a can of worms on that one. How does it get from a planet? If it's formed by a planet, is this a planet that might have exploded at some point?
Yeah, so probably it ran into another planet, or planetoid, planetesimal, something like that. So you've got things that are not as large as the Earth probably, but you've got a lot of asteroids out there that are quite large and have these iron cores, and they run into each other, particularly in the early solar system. And that's what breaks them up. And then they, of course, fly around the solar system for a while, and then they end up crossing Earth's orbit. So yeah, exactly. It's a kind of a failed planet, or a planet that blew up because of another collision.
Cool. See if we got some questions here. Everybody's loving this. See, I knew they would. See, Jennifer says that's awesome. See, I'm telling you, people are loving this.
All right.
I was so excited to get you on. So you wrote a book, right?
I did.
Expect to have a cut here. I'll show this, and you can talk about it. There you go. Boom. See?
All right. That's it. Yeah.
Talk about your book.
So the book is as you can see the title, How Rocks from Space Led to Life, Culture, and Donkey Kong. It's just kind of a discussion of why meteorites have kind of set the stage for planet Earth and the life on Earth, but also how they've kind of changed how we developed as humans. And that of course goes from the destruction of the dinosaurs and the rise of the mammals and how that all happened, but also kind of once we became humans, how they influenced religion, how they changed the ancient Egyptians, how they changed in Mesopotamia, all the different kind of inflection points in Christianity or Islam, and the different kind of ways they've changed human culture. And, I just found it to be a really fascinating subject. And I thought, other people might find it interesting as well. So that's kind of why I did it. And I tried to do it to, a general audience of smart people, but not experts in meteorites. I hope anyone who picks it up enjoys reading it. And I did all the little, cartoons on my own. So I did a lot of figures on it. And I think, at least I like to think it helps explain these types of topics. So.
Well, now that you said that, how did it change, human culture?
Well, I mean, religion is certainly something that a lot of people, follow on Earth. And actually, two of the most followed religions, Christianity and Islam, would be non-existent or very, very different religions if it weren't for cosmic interactions, like meteorites or meteorite impacts. And just for one story, I think is really interesting. The story of Sodom and Gomorrah, which is the story of how in the Bible an entire city was destroyed because they were doing some sinning. If I can paraphrase the story very quickly, but what probably that was a meteoritic air burst. And there's some excavations going on right now in I think it's in Syria, maybe, that people believe that they found the ancient cities of Sodom and Gomorrah, and it was from a meteoritic air burst. So there's layers upon layers of stories like this that these events that happen in the Bible or in the Quran about kind of the physical explanations for them often come from the sky. The Star of Bethlehem was a comet. So these types of things are certainly stories in the Bible and other religious texts, but they have physical meanings and they have kind of reasons why they existed, and the timings that these things happened are really interesting in how they kind of changed how religion was developing.
That's interesting. My question I was thinking about, when you look at something like the crater in the crater in Arizona,
Mm-hmm.
when that thing hit, did it go underground or did it just blow to pieces?
A little of both, and we're actually not 100% sure, to be honest. So the original thought was that there would be a large iron mass under the crater, and actually the guy that tried to mine that, he wanted the iron for it. So they dug quite a bit, and they never were able to find it. And so if it's down there, it's difficult to find. So it probably broke up a lot. They found chunks of the meteorite all around the area. So probably what happened is it got really close to the Earth, and it hit the Earth and then went into a bunch of different pieces. And it was an iron meteorite similar to the one that I held up earlier, similar to this one. So it was a very large iron meteorite, and it was probably the size of a school bus or something like that.
To think that, well, I guess the velocity it was coming in, to cause that big of a crater like that.
It's fast. Yeah. Yeah, I know. You've been there. You see, how big it is. And there's a picture in the book about like the visitor center, which is, a normal sized building. And you can barely even see the visitor center. It's a shot from the sky. And then there's this huge crater. And then you think about the size of the meteorite that made that. It was smaller than the visitor center. And it's just absolutely remarkable to think about something that large or that small comparatively making that big of a mess.
Absolutely. I can't imagine. You would think this thing was like super duper duper huge.
Yeah, it's not that big compared to the size of the crater, for sure.
That's nothing.
Yeah.
When you look at the crater, that's crazy. I don't know if you guys have been out there, but if you need to go to the Arizona crater, because it is something to behold.
It is pretty cool.
It is really cool. So, are you planning on going out to any sites or anything?
Not right at the moment. I guess I enjoy meteorite hunting, and certainly really like going to various craters. There's a lot up in Canada, and there's a lot of great craters around. But I guess I thrive in the lab. I'm not as good as finding meteorites as I am picking them apart and dating them. So I guess I spend my time in the lab instead. Other people are better at going to find them, so I let them do that.
Now, how long does it take to pick one apart like that?
Some we don't pick apart, so they're easy. We just kind of grind them up and then measure them. So that can be a matter of days to weeks. But if you're really picking them apart, it can be months to sometimes 6 months to a year. So it takes a long time. But in the end, it's kind of cool to get the data and figure out how old something is, or where it came from in the solar system.
Now, I always, like I said, I have this vision of like around the dinosaur time of the Earth getting hit by something so big that it actually knocks us off kilter, to change everything. I mean, is that a possibility from the Earth's past, or is that what happened on the moon, or other planets?
When you get hit by a very large meteorite, that certainly changes, the velocity of the planet, things like that. So it definitely can change where you kind of sit relative to the sun. Something small is not going to make much of a difference, though. So even something like what killed the dinosaurs, that's not going to change the orbital dynamics of the Earth. It's just going to cause the atmosphere to be very, very different, and the climate basically is going to change drastically, very, very quickly.
Okay. Yeah.
So unless it's really, really big, it's not going to change our relationship to the sun. But I think probably the one that caused the moon forming impact probably changed how we kind of orbited the sun. But it's unknown, at least to me, how much.
As a scientist, do you have any desire to go up into space and see these things firsthand?
I'd love to. Yeah, I would love to. I'm not trained to. So I would be a danger to myself and those around me, but I would love to do it.
You'd be the guy in the spacesuit going, "Oh, let me out a little farther. I want that one."
Yeah. I know. I'll let the professionals do that. The men and women that do that for a living, I think they're far more prepared for it than I am.
I just find like you say, the ones that go back billions and billions of years, I just find that so fascinating. Because when you think about it,
the depth of time that we're talking about is just difficult for the human brain to comprehend. And I'm totally with you. They're old.
that just boggles my mind. It even boggles my mind to think that, where even like where Mars is, or even Jupiter, that you're looking at something back in time. Even with that, I mean, the light coming from all that stuff, already happened millions of years ago.
Yeah, well, not so much Jupiter and Mars, but things beyond our solar system. That's
Sure.
absolutely correct. I mean, if you're looking at different star systems,
Yeah.
I mean, we're looking back in time. What happened, a million years ago, and it's pretty wild to think about that. I mean, our solar system is relatively small compared to the distances of, James Webb and Hubble, that we've seen these really deep space, deep time type things. Within our own solar system, it only takes, 8 minutes, 8 seconds. Now I'm embarrassed. I can't even remember, from light to get to the Earth. It's 8, whether it's 8 minutes or seconds. I think it's 8 seconds. But that's as far as basically we're looking back in time for our own solar system. But for distant solar systems, it's really a long, long time.
I think of that movie Explorers that was out years ago, when the aliens came and the aliens were watching I Love Lucy, because that's what they thought we watched here.
Oh,
because that's the TV stuff that's the stuff.
Exactly. Yeah. That's funny.
But what you do just fascinates me, and the whole study of it.
I'm glad to hear it. I certainly enjoy it, and I'm glad other people are enjoying it as well.
Now, do you teach at all? Do you teach people, to?
I don't teach classes. I've got students that I do research with, but I don't teach classes right now. I'm not really at a university, or I'm in a national laboratory, so we don't really teach classes there. We just do research for the most part.
Wow. So how many times? I mean, how often do you get samples to work with?
We generally try not to overload ourselves with work. So, we try to have maybe 2 or 3 projects going on at a time. My working group basically will have 2 or 3 projects we're really excited about. So we'll be working on 2 or 3 at a time. So for instance, we just published a paper about, the origin of water on the Earth and moon system, and so we were looking at rocks from the moon to do that. So
Hmm.
that, took, I don't know, 6 months to a year to kind of do that. And, in conjunction with that, we were working on a couple other meteorite projects, but, I can't do too much at once. And my colleagues and I, we don't want to overload ourselves. So, a couple projects at a time is basically what we can handle.
When you talk about finding, about like biological things on these meteors, is water some of that? I mean, like you just mentioned, water. Are you able to find the little dry droplets of water?
So actually, meteorites are really interesting. So especially the ones that formed in the outer solar system,
Uh-huh.
like Murchison I mentioned earlier, it's got about 15% water, 20% water in some of these cases, and
Wow.
that's like a sponge that's not really rang out very well. Like a dish sponge or something like
Right.
that. So they're really quite wet, and a lot of that comes from ice that from where they formed. There's just a lot of water in the solar system and a lot of water in the galaxy and the universe. It's just we don't have that much of it in the inner solar system because the sun's so hot and it kind of drives it off and
Mhm.
evaporates it. But the outer solar system is quite wet. There's a lot of water in a lot of these meteorites.
Yeah, and water is the basis for life too. That's what makes you wonder about stuff.
Exactly. Exactly. Yeah, makes you really think that there's got to be life out there in other stellar systems because all the ingredients are pretty easy to come by.
Hmm.
Assembling them in the right ways, of course, is the trick. How that happens, like I said, I'm not going to pretend to have that answer, but
Right.
we do know how the ingredients are made, and they're pretty much everywhere in the galaxy.
I just find it fascinating that you guys can pinpoint where these things come from because, I mean, they've traveled millions and millions of miles, through space.
Yeah, yeah, it is cool. It is cool. I agree. But if we know the asteroid belt, and we can take the look something called the spectra. So basically, like what the rocks look like, and you can kind of match that up with the meteorites
Uh
as
huh.
well. So we know where most of the loose material is in the solar system, and that's in the asteroid belt, and that's where we get the vast majority of our meteorites. There's a few that come from the moon, and there's a few that come from Mars, but 99% of them probably are coming from the asteroid belt, which is between Mars and Jupiter. Um,
For people that want to look at like an asteroid shower, I mean, we all hear about the Perseids, but there's other ones throughout the year too, right?
yeah, there are some other ones, some other minor ones. Most meteorites don't come during those types of showers, though. They just kind of come randomly. You may get a lot of kind of dust and things like that, and that's what gives you that nice show. But most of those are not going to come down as meteorites. They're too small. They usually burn up in the atmosphere. Most of them are grains of sand size, but you still get that show because they're coming in at such a high velocity and then burn up. So it's like a firework, whereas you never see the firework after it falls down because it is just burned up.
See, that's the other thing I find amazing. Like you say, it's sand. I mean, when you think about the space shuttle coming through, you think about a space capsule coming through, or even like when Skylab crashed. I mean, you think of big things like that catching fire and putting on a show, but I mean, to think that they're the size of a grain of sand.
Yeah,
Wow.
yeah. You can get when you're looking up stargazing at night and you see a shooting star. That's not a star. That's the size of a sand grain. Yeah,
Just craziness.
yeah. It
It's
is
so
pretty wild.
fascinating what you have to say. I mean, this is just mind blowing. It really is mind blowing. What's the biggest meteorite that they found on the Earth?
I believe it's the Hoba Meteorite. It's found in southern Africa. I think it's in Namibia, and it's so large they haven't been able to move it. It's just a huge iron meteorite block. So you can go there and you can kind of wander around it and sit on it and look at it, but it's just a huge iron block, basically, um, and it's it's big.
Imagine what the impact for that sucker was like, boy,
It
man.
was probably pretty good. Yeah, I'm guessing it landed a long time ago and then has kind of been uncovered by erosion. I think they've certainly studied it and know when it landed, but I don't know it off the top of my head.
Yeah, it just, wow. Just thinking about this gigantic rock coming from, up there and then impacting. It's like, it kind of reminds me of like somebody dropping a bowling ball off your roof.
Yeah, only at 600,000 miles an hour or 60,000 miles an hour.
That's a big bowling ball.
Yeah, it's a scary thought.
It is a scary thought, to know these things are doing this. How frequent? I mean, like I said, we talk about the little pieces of sand, but for the bigger ones, how frequent do they fall, or is there a pattern? Like how volcanoes will erupt in a certain time pattern, things like that. How frequent do these big ones fall?
It's hard to say. We don't really know if there's a pattern to it because humans have not or existed that long, and we certainly have been studying these things for more than 40, 50 years. So it's hard to say. Looking back at kind of layers of Earth, there are certain time periods in which we see more meteorites of significant size, and probably what happens is that you've got two planetesimals that collide in the asteroid belt, and then material starts coming toward the sun, and we get in the way. So in those cases, you do see more, but those are on the kind of the 100,000 year time frames. It's hard. It's not like more come in March or anything like that.
Right.
So from a geologic perspective, human timescales, there's no real difference. But when you talk about geologic timescales, maybe you see increases. When you have large impacts that happen in the asteroid belt.
And I was just thinking it might be a good indication too that we are doing stuff to our atmosphere. Because like the moon gets all those impacts because the atmosphere is so thin. I mean, people, the scientists like you can keep an eye on that and see, well, gee, we're starting to get more of these impacts. Let's look at the atmosphere and see what's going on.
Mm-hmm. Yeah, that's I'm not sure how much atmosphere we're changing that quickly that it would impact the rate of meteorites, kind of surviving. But that's actually something I've never thought about. That's an interesting point.
Yeah, what do you like to tell people that want to get into studying this stuff?
Do it.
Yeah.
If you're interested in it, do it. There's even if you just want to look at them, you can find meteorites on eBay. You can find them at museums. There's a lot of meteorite dealers that you can find them on eBay and buy them and then look under them a microscope and you can find something interesting. I mean, there's so few people that study meteorites. Even just somebody with a microscope that's not fully trained in it can make some really important discoveries and make really important things happen in science. So much like people that study the stars and find new comets or things like that for amateur astronomers. If you're interested in meteorites, just buy a couple online and a microscope, and you're going to find something interesting.
You're so enthusiastic about this. I mean, if I was around you, I would really be studying these things because you just draw people in with your enthusiasm about it. I mean, you obviously love what you do.
I do love what I do. Yeah, I do. I think it's great.
What do people, you say you meet somebody like, and this is just a random question, you meet somebody on the street, they ask you what you do. What's their reaction usually?
They just keep walking.
Okay.
No, I mean, most people are pretty interested in the general topic of meteorites. Most of them go, that's a job. But yeah, there's a lot of jobs. I make the point in the book that there's more people that farm alligators in Florida than that study meteorites. And so if there's room on this planet for people farming alligators, there's room on this planet for people studying meteorites. And the way I look at it is if we care about where we came from, then we have to study meteorites, and because that's ultimately where we came from.
Right.
At some point back, at the beginning of the solar system, if it wasn't for meteorites, we wouldn't be here. So, I like to think of it as just studying our own history. And a lot of people do that.
Are you ever taken aback when you find something that just like we talked about, that one that was billions and billions of years old?
Mm-hmm.
I mean, does that stuff really impress? I mean, as a scientist, scientists aren't supposed to be impressed easily, right? You guys are supposed to be stoic. And
we're impressed all the time. That's why we do it. It's just exciting. I mean, we're all like little kids. Come on.
Oh my God, this is so old. Check it out.
Yeah, exactly. Yeah.
That's just really cool. I mean, it's just I just think I never thought of really cutting these things up and studying them and dissecting a rock. I just think it's so cool what you do.
It's fun. Yeah.
What do you think? And as far as and I know I know they're all rocky material. Do you think the iron ones cause more impact than the others because they are iron?
They do have more like damage when they arrive, yeah, because they're like a bullet. They're made of bullet type material, iron and nickel. Bullets are made of lead, but it's still a very dense metal that's coming down. So they make a pretty big impact, and they certainly cause a lot of damage compared to some of the ones that break up a little bit more. So yeah, it matters with what type of meteorite is actually happening for how much of the crater is caused and things like that.
When you talk about it being like a bullet, it reminds me of like buckshot. I see these guys with their muskets loading their rifles, but they're just like giant buckshot coming down out of the sky.
Yeah, if you turn it to the ground and shoot the ground and see what happens.
Oh my! I've learned so much, and I know everybody else has too. I mean, what are the chances? Because you're always hearing these reports about these big meteorites that are coming close, definitely close to the Earth. What are the chances that something's going to come that close or impact?
Again, it depends on the time scale. The chances are very good that it'll happen in the next billion years, but on a human time scale, pretty low. Luckily, these things are rare, and on our time frames, 100 years, 1,000 years, things like that, it's pretty low. But it's going to happen. I mean, it's happened many, many times over the history of the planet, and it will continue to happen. It's just, are we around to care is the real question.
Well, that's the thing, because you hear all this about Planet X, and the asteroids that are going to hit and blah 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 blah, and like I feel like you. I mean, it's a fluke thing when they do get that close, if they come that close.
Right. Yeah. I mean, yeah, it is. But statistics always win. There's a lot of rocks out there, and we're going to hit one eventually. But I guess just have fun while you can, and
don't worry. Don't sweat the stuff falling out of the sky. It's all
that's
good.
right.
Yeah.
Don't worry about it.
Don't worry about
it's going to happen, and hopefully not while we're around.
Let's see. Okay, what do you have to say to people who actually want to go out and find these things like the Meteor Men?
Just enjoy hiking. I mean, you're probably not going to find one every time you go out. You can kind of do your research and find out where people have found them in the past, and that's the best place to look. The easiest place to look is places where there's no vegetation or very little, other rocks. So dry lake beds and things like that are the best places. And of course, if other people have found them in the past in those areas, then likely they broke up and there's, many pieces still yet to be found. Right. So that's the easiest place to find them. But they're not easy to find. They're just, if you like going for a hike, then go for a hike and, kind of look at the ground a lot.
And take some shovels.
Yeah.
Take some shovels and large equipment to pull them out of the ground.
Well, most of them aren't that big, so you probably don't need too much equipment. So.
How do you feel about the show like that, Meteor Men? I mean, because those guys were going out looking for this stuff. I mean, did they portray it correctly, or did they make a how TV channels can be? Did they make a mockery of it, or did they pretty well play it straight?
I guess to me it was fine. They're out there. They're not making stuff up. They're out there hunting for meteorites, and that's totally fine. I guess they were monetizing it, of course, because that was their job. They find a meteorite and say, "Cha-ching! This one's worth $600." Okay, well, it's worth a lot to scientists. It's hard to put numbers on what that's actually worth. I mean, of course, you can sell it on eBay for $600. Right. But to me, I just need a slice of it, and I can figure out, how old it is or something like that. So, I guess at some level it's good because it makes people interested in meteorites. But at some level it's bad because then they look at it as a commodity as opposed to knowledge. So, I guess I see both sides of it. I think it's great that people are becoming interested in it. But is it something that's just a commodity, like finding a nugget of gold or something? It's worth more scientifically than that to me.
Okay. All right. So what's next for you?
What's next for me? Man, I don't know. I just I'm enjoying the ride right now. I'm enjoying, I enjoyed writing the book. I enjoy doing the work that I do. So I'm going to continue doing that while I can. And if something else comes along, then I may pick that up too. But, I just like studying meteorites and talking to people about them. I think it's a cool thing to do.
How can people find you?
I'm on Twitter, I guess. Brennecka at Greg Brennecka is probably the easiest way to find me. And then, Google is something that exists too. I can be found on Google.
Well, I want to thank you for coming on. I really appreciate it. I learned so much tonight. I was literally dying to get you on because I wanted to talk to you about this stuff. I've been, like I said, I'm a space nut, and this kind of stuff fascinates me. Just like the thing with learning about the sheet, on the top of the house and all that.
Yeah.
But thank you so much, and I really appreciate you coming on, sir.
Well, thanks a lot for having me, and thank you and everybody else that's a space nut, because I'm right there with you. It's really cool stuff, and I really appreciate you talking about it.
And I would love to get you on another, later on to talk more about this at some point. So
okay, keep me posted.
All right, sir. Thank you, and have a good day.
All right, take care. Bye-bye.
Okay, bye-bye. Okay, that was a fun interview, and I don't know about you guys, but that was fascinating. Just seeing those meteors from space, that's something. That's something. Tomorrow we're shifting gears. Stephen Gregory is going to be on with us. He's an award-winning journalist, and he is going to be talking about unsolved crimes. And he has his own podcast about that. And so he's going to be joining us tomorrow, and he'll be back at the regular time at 6:30 p.m. I want to thank everybody for joining us tonight. In fact, I'll put a link up here to Professor Brennecka's book, so you guys can find it because it's available on Amazon. And it's something that I'm going to be reading too because, like I said, I'm a space nut and I want to read all that stuff and read as much as I can about it. All right. If you like the show, share it with 5 people. If you hated tonight's show, share it with 5 of your enemies. We're equal opportunity here at California Haunts Radio. Also, subscribe to please subscribe to our YouTube channel. We've got more than 200 videos on there, and they're all shows and different topics, and we're real proud of what we've done. So subscribe. And, we are a nonprofit organization. And like everybody else, we have costs and expenses. And if you could help us out a little bit with that, that would be great. That would be at paypal.me/California Haunts. Or if you have issues with PayPal, go to Venmo and type in California Haunts and, and just drop us a little bit there. We'd really appreciate it because we want to keep bringing this show to you. And the equipment you see comes out of my pocket, but we want to keep bringing great guests like the Professor on and the others that we have on. Okay. But anyway, come visit us at CaliforniaHauntsRadio.com, and don't forget that we're going to be doing a public ghost hunt with us called Ghost Tour, where we take you out and show you. You get to use all our cool equipment. We even have some of the equipment that they use on TV. I'm not going to mention the show, but the show that show with the GA that uses all that really cool equipment. We have some of that stuff, and you'll get experience doing that. It will either be in a haunted hotel or we'll be out in the cemetery. So I mean, either way, you're going to get a treat because we, don't give our equipment out to just anybody. And if you do happen to get any evidence, we will use it and put your name on the website, and you get credit for it. So there you go. All right. Anyway, I want to thank you guys for coming tonight. I will see you tomorrow, and I'm going to go ahead and run his information. Here we go. So his profile and everything is at harpercollins.com. And of course, the book is Impact. So be looking for that, and it's available at Amazon. There you go. And again, thank you guys so much. I will see you tomorrow at 6:30. Bye.